Okay, so as explained in the summary video, we can now make tubes which not only show the volume but also show a concentration. So we can actually make tubes with a particular volume with no concentration, that would be like water, or we could make something with a concentration and that might be glucose or whatever is in there. So I've got a mill here of 20 millimolar, and I can now do some pipetting to take and mix those volumes in some sort of sensible way. So if I put the same amount of water and this 20 millimolar solution, I get 10. And if I take 100 of that and put it into here, then I get something sensible at the end. So um, the way that this works now, of course, is that we have to not just track volume changes, we've got to track concentration changes. Now, anybody who has ever done biochemistry under my tutelage knows that the mantra for dealing with biochemical calculations is that you follow the mole. So although we quite rightly express the constituents of a liquid by concentration. We say the glucose is 10 millimolar and this particular agent is 10 mgs per mil or whatever. When we're doing transfers, it makes more sense to think in terms of quantity. So that's how we're going to run things. We're going to define the properties of this substance as a concentration. But when we do the transfers, we're not just going to be interested in the volume change, we're interested in the quantity change as well. Now, that means that when we've done the addition, we actually have to make sure we keep track of the quantity that's in the tube. The initial quantity is just whatever the volume was to begin with times what the concentration was to begin with. Having gone through the checks to make sure that the volume is okay, and that's something you have to do when you're sucking up, you then calculate the new quantity in the tube, because it is what it was and what you've added or taken away. And then you adjust the volume based on that very clear, distinct volume change, and then you adjust the concentration. And of course, the concentration is the new quantity divided by the sanctified volume. Now, the only time that this can get you into any trouble is if the volume is zero, because then you start dividing by zero, you get crazy things like not a number or infinity or minus infinity, that sort of thing. So to try and just stop that from happening, we have these little lines of code here. So every transaction we do is going to be an amount of volume and an amount of quantity of the substance. So when we do our pipette actions, when we're doing the suck up, after doing the checking that we're not trying to suck up greater than what's in the tube, we then go through that same sort of process. What's the quantity change? Having determined what the quantity change is, what's the new concentration? Having determined what the quantity change and the volume change is, send that to the active tube, because that's the transaction that's going to be made on the active tube. A little bit simpler with dispensing. Again, we need to know what the transaction is, what's the volume we're adding, what's the quantity we're adding. Well, the quantity we're adding is quite simple. It's the concentration times the volume. This time, though, when we do the dispensing, we're not changing the concentration, so we don't have to worry about that term. The only other time we do the transaction is when we're making a new tube. So when we create a new tube, not only do we have to now think about what volume we're creating, we have to think about what concentration we're creating. And that concentration, again, is reflected by a change in quantity. So to do that, we check our input fields to see whether or not anything's coming in, and we check our concentration field to see whether or not we're going to add some quantity as well. And then we send those values to liquid in tube, adjust volume as before. So this is now very powerful. We've now got something where we can track concentration of volume, and you can almost see an exercise for the students building up here. Can you manipulate the concentration in the tubes? We're going to now, in the next session, ramp things up so that we do that exact same thing, but for an infinity of substances. And of course, that's when things really start getting you can really start seeing the potential for applying some rules to the interaction of those substances.